Welcome to another unit in the ISM Statistics 1 exercise set, this time with an exercise on linear regression. What's about the exercise? It is assumed that the number of points achieved in a math exam is linearly related to the hours spent learning beforehand. In this context, 5 students have been interviewed and the results have been summarized in the table below. What's to do with the information? A. Calculate the coefficients of the linear regression line that describes the relation between the two variables. B. Interpret the coefficients calculated in part A. And C. Calculate the coefficient of determination r squared. However, before we can start, we have to do some preliminary work. For this we need our original data table, and we can start by thinking about which of the two variables is the dependent, which is the independent. Well, if we think about the exercise, it clearly said that learning influences the output of the exam. Might also make sense because usually learning happens before or should happen before the exam, and having a certain amount of points happens after I have written or taken part in the exam. So here we can say x, our independent variable, that's learning, our dependent variable, the points in the exam, that's y. Then we add 3 additional rows. In the first row we calculate x squared, so all the x values to the power of 2, so 8.5 to the power of 2, 10 to the power of 2, 1.5 to the power of 2, 1 to the power of 2, and 9 to the power of 2. Then we do the exact same thing for y. 82 to the power of 2, 94 to the power of 2, 58 to the power of 2, 51 to the power of 2, and 87 to the power of 2. Finally, in the last row we calculate x times y. So 8.5 times 82, 10 times 94, 1.5 times 58, 1 times 51, and 9 times 87. However, we're not so much interested in the raw data we just calculated here, but in the averages. So as an intermediate step, we calculate the sum of all 5 variables and then divide this by 5 as we have 5 observations. So we get as an average for learning 6 hours, for the average number of points in the exam 74.4, for x squared 51.3, for y squared 5818.8, and for x times y 511.6. These are the values we will then use in actually calculating the coefficients and calculating the coefficient of determination. So if we start, the first thing to do would be calculating the slope of the regression line, which follows set formula. So here we start with the part above the fraction line where we have the average of x times y, our example 511.6. From this we subtract the average of x times the average of y. So 6 times 74.4. And all of this is divided by the average of x squared, so 51.3 minus the average of x squared, so 6 squared. Inserting the values and calculating this expression gives us a slope of 4.2614. This slope we can then use to get our intercept. The intercept is defined via the average of y minus b times the average of x. So here we have 74.4 minus 4.2614 times 6, resulting in a value of 48.8316. So what do those two values mean? And with this question we're already at part B. It actually makes sense to consider the intercept first, because the intercept would say if we have someone who did not learn at all, so learning hours are 0, he will still get 48.8, so roughly 49 points in this exam. And then for each hour he spends more learning, he will get an additional 4.26 points. So 4 to 4.5 points. So in this case makes actually sense to interpret both, to interpret the slope and interpret the intercept. And well, with this interpretation we also already finished part B, and we can turn to part C, calculating the coefficient of determination. For this we still need our regression line, because we have need of one additional row in our table, and this row needs to contain y hat squared. What's y hat? Y hat is the value we get when we insert the x value into our regression line. So here for the first one, this would mean we calculate 8.5, that's the x value, 8.5 times 4.2614 plus 48.8316. This would be y hat. As we have here y hat squared, we would need to square this result, and this would give us a value of 4234.1. And well, then we would do the same thing with 10. We multiply 10 with b plus a, and the result is squared. So we get this result for 10, this result for 1.5, for 1, for 9. Then, if we have all 5 values, again we sum them up and we divide them by 5, generating the average. That's actually the value we are interested in, and which we are later going to compare to y squared. Here we can already see that y hat squared and y squared are actually pretty close to each other, which is actually a good sign. Why is this a good sign? We can switch to the next slide, and here for the coefficient of determination we have the following formula. For this, first we need the average of y hat squared. This was the last one we calculated, that's the 5813.2. From this we subtract the average of y squared, so 74.4 to the power of 2, and we divide this by y squared and its average, so here by 5818.8 minus again 74.4 to the power of 2. So if we insert those values here, we get as a result 0.9802, which means that our regression line, therefore the learning, can explain 98.02% of the variance of our dependent variable, so can explain roughly 98% of the points someone gets in the exam, which is actually a pretty good result, considering that the coefficient of determination can at most be 1 or 100%. So this is a really pretty good result. And well, this then already concludes this exercise. I hope all of you enjoyed listening to it and learned at least something from it. So until next time, see you and goodbye.